Yo, what's up everyone? Patrick here, welcome back. Moving on to the next question, another equation dealing with multiple absolute values. So we got the absolute value of 2x minus 3 equals x times the absolute value of x minus 4. So like I did in the previous example where we had those two absolute values for the equation, what we got to do is we got to take each absolute value, split it up into a piecewise function. At least that's what I do. So this absolute value of 2x minus 3, we can rewrite that as positive 2x minus 3 as long as what? As long as 2x minus 3 is greater than or equal to 0, which means when x is greater than or equal to 3 over 2. Right, so this would go over here. So if x is greater than or equal to 3 over 2, it would make this be positive or 0, but for the most part it'll be positive. And if this is positive, then we just leave it as is. But if it's negative, right, if it's negative, so that's going to happen when x is less than 3 over 2, then we have to take that and multiply it by -1 to turn it into a positive. Like that. Right, so this is equal to that piecewise function. And then this x we don't have to worry about because it's not within an absolute value. But this absolute value of x minus 4, we got to do the same thing. So notice this stays as x minus 4 as long as x is greater than or equal to 4. Right, then it's going to be positive, it'll stay as is. But if it's less than 4, then that expression within the absolute value is going to be negative. To turn it to a positive, we got to multiply it by -1, like that. And so notice that the two breakpoints that we're working with for this equation is 3 over 2 and then 4. So if I put these in a sign chart, 3 over 2 is less than 4. And then we got positive infinity, like that. Notice that this absolute value, 2x minus 3, it's going to be negative on this interval, but then when x is greater than 3 over 2, it's going to be positive, positive, like that. Right? This negative means there's just a negative in front of it. This positive means there's just a positive 1 in front of it. So it just stays as is. And then x minus 4, the absolute value of x minus 4 is going to be negative here, and then positive. Right, when x is less than 4, so these two intervals, there's going to be a negative in front. When x is greater than 4, it's going to be a positive. It's going to stay as is. And so now what you want to do is you want to work with those three intervals for this function. So the first interval is when x is less than 3 over 2. Well, when x is less than 3 over 2, notice that this absolute value, 2x minus 3, is going to be negative 2x minus 3 equals this x, we would plug in like that, and then this absolute value of x minus 4 is going to be negative as well, so there would be like a negative in front, like that. This is not x minus that. You're multiplying this. This is like a -1 here. That's multiplying by both of these. Right? So it's like a negative. You can write this as x times -1 times x minus 4. It's not x minus 4. So just be careful over here. Right? So I plugged this for that and then this for that. Because on this interval, both of these have a negative in front. And so now we just solve this. So this would be -2x plus 3. There'd be like a negative x. This and this, let's combine. So it'd be like -x squared plus 4x. Like that. And then what I'm going to do, I'm going to bring this over. So we'd have x squared. Bring the 4x over. -2x minus 4x gives us -6x. And we got plus 3 equals 0. So notice this is just a quadratic equation over here. So I'm actually going to take this, I'm going to rewrite it up here, because we can't factor this smoothly. There's no two numbers that multiply to 3 and then add up to -6, so we're going to have to use the quadratic formula on this. So we would have x equals -b, which would be 6, plus or minus b squared, which would be -6 to the power of 2, which is 36 minus 4 times the a value times the c value. That's going to be all over 2 times a value. So we would end up with 6 plus or minus 36 minus 12 would be 24 over 2. Now the square root of 24 we can rewrite as the square root of 4 times the square root of 6, which would be 2 root 6, like that. So square root of 24 is the same as 2 root 6. So we'd have 6 plus or minus 2 root 6 all over 2. Then from here, we could factor out a 2 from both of these two factor, or we could split this up as like 6 over 2 plus or minus 2 root 6 over 2. Notice this would just be 3. These 2's cancel out. So we'd end up having x equaling 3 plus or minus root 6. Those are what the solutions would be to this. Right, so notice we got two solutions. We got x equals 3 plus root 6, and then we got x equals 3 minus root 6. So those are the solutions to that original equation that we wrote here. But then we have to check, are these solutions within that interval right there? And notice these are exact values. We got this square root of 6. So if you're not using a calculator, this could be sometimes tough to deal with. Well, 3 plus root 6 is going to be greater than 3 for sure. And notice that anything greater than 3 is not less than 3 over 2, which is like 1.5. So we know this solution is not going to work for sure for this interval. How about this solution though? The 3 minus root 6. So this one's a little tougher to see. Is this here going to be less than 1.5? It's kind of tough to see, but what you can do is you can take the perfect square numbers that are closest to this. So notice 3 minus root 9 would be 0. And then 3 minus root 4 would equal 1. Right? Root 9 is 3. 3 minus 3 is 0. Root 4 is 2. 3 minus 2 is 1. And so notice root 6 is going to be between those. So we'll have 3 minus root 6. So even though we don't know what it is, notice it's going to be between 0 and 1. And any number between 0 and 1 is going to be less than 1.5. 1.5 is like over here. Right? So this number is going to be less than 1.5. Right? So sometimes you got to do this sort of work on the side and kind of work out where this is going to fall. Sometimes it's even tougher to figure out than just this. Right? But notice that with this 3 minus root 9, 3 minus root 4, it's easy to tell that 3 minus root 6 is going to be between 0 and 1. And any number between 0 and 1 is going to be less than 1.5 or less than 3 over 2. So this solution does work. And so this is a solution to that equation right there. So we would write that. Right? That's going to be one of the solutions to this overall equation. Right? So that's just the first interval right there. So now what we do is we move to the next interval. So we would have when x is greater than or equal to 3 over 2, but it's less than 4. So notice that this is positive on that interval, so it stays as is. We got the x as is. And then the x minus 4, absolute value of x minus 4 is negative on this interval. So you'd have a negative x minus 4 here, like that. So we could rewrite this as negative x minus 4, like that. Negative x squared plus 4x. Bring everything over. We'd have x squared 2x minus 4x gives us negative 2x minus 3 equals 0. And this actually factors smoothly. Luckily, we don't have to use the quadratic equation or formula, rather, on this. Right? This factors into that right there. So we would have x equaling 3, x equaling negative 1. But then we got to check whether these are within this interval. Notice x equals negative 1 is not within this interval. This is for x values between 1.5 and 4. Negative 1 is not on that interval, but 3, notice that it is within this interval. It is between 1.5 and 4. So this solution works, and so that is going to be one of the solutions to this overall equation. And you could check it. So you can say, if we plug in 3 here, 2 times 3 is 6, minus 3 is positive 3, absolute value of 3 is 3. And then we'd have 3 times 3 minus 4 is the negative 1. The absolute value of negative 1 is positive 1. So we'd have 3 equals 3, like that. Right? So notice that this does work over here. And then notice that negative 1, this is a good example to show actually, because it's fairly easy to plug in. So negative 1, if we plug it in, notice we'll have 2 times negative 1, which is negative 2 minus 3. So we'll have absolute value of negative 5 equals negative 1. And then we'll have negative 1 minus 4, which is absolute value negative 5. Absolute value negative 5 is 5 negative. This would be 5 as well, but notice that 5 does not equal negative 5. So this does work on that equation we had here after we got rid of the absolute values, but it doesn't work on the overall equation with the absolute values as I just showed here. Right? So you got to be careful in checking the solutions you get, whether they're on the interval that you're working with. And then the last interval is when x is greater than 4. When x is greater than 4, both absolute values are positive, so we'll have 2x minus 3 equals x times x minus 4. 2x minus 3 equals x squared minus 4. Bring everything over. And then we'd have 0. Sorry, this should be 4x, my bad. So I'm going to bring everything to the right side. We'll have x squared minus 6x plus 3, like that. Notice this is the exact same quadratic equation that we had in that first interval that we worked with. Right, when we plugged it into the quadratic formula, what were the solutions that we got? Well, we got x equals 3 minus root 6, and we got x equals 3 plus root 6. Well, notice 3 minus a number is definitely not going to be greater than 4. So that's inadmissible, but it was admissible in that other interval. So that is a solution to the overall equation, but we didn't get that solution from this. We got it from that other interval. So you got to be careful. But this does end up being an overall solution to the equation, but we didn't get it from this interval. Notice 3 plus root 6, well, is that going to be greater than 4? Yes, because 3 plus root 4 is equal to 5. And root 6 is greater than root 4. So we know 3 plus root 6 is going to be greater than 5, which is going to be greater than 4. So this would be an admissible solution for this overall equation. So even though it wasn't admissible in that first interval, it was in this last interval. Right? So both of them did finally end up being a solution. All right, so those are the 3 solutions right there. So that -1 that we got there, notice it's not part of the solutions. So just be careful. Right, so those are the 3 solutions to that equation.